Exponentials and logarithms are inverses of each other, which means they have the opposite operation. What that means mathematically is if I gave you 2 to the third power, well, what is 2 to the third power? 2 times 2 times 2, which is 8. Well, if I said log base 2 of 8, what I'm really asking here is, what was the exponent? I'm going backwards. It's the reverse operation. The inverse of an exponential is a log. A log solves for the exponent. So here I'm reading this as 2 to what power is 8? And the answer is 3, and that's the connection between exponentials and logarithms. They're just inverses, they're opposite operations, which means rules of exponents, the opposite will be rules of logs. For example, if I gave you x squared times x to the 3, that would be x to what power? To the 5th, because when you multiply, you combine by adding. For logarithms, if you have log of, let's say, x plus log of y, when you add, you combine by multiplying. For exponents, if you have x to the 7th over x to the 2nd, that would be x to the 5th as well, because when you divide, you combine by subtracting. With logs, when you subtract, you combine by, you guessed it, dividing. X to the 3 to the 4. So an exponent raised to another exponent, what do? You multiply. So over here, if you have an exponent, you bring it in front to multiply it. If anything to the 0th power is 1, that's why log of 1 is equal to 0. So make sure you know your rules of logarithms as well as your rules of exponents, because you may encounter questions where you're asked to solve a logarithm. And here's just 2 examples. If you're asked to solve a logarithm where the case is it's just equal to a number, change it back to an exponential. Now, in this case, the base of a log is implied to be 10, just like the base of a natural log is implied to be e. Otherwise, they have to give you the base. But in this case, the base is implied to be 10. So my base is 10, my exponent is 2, because a log solves for the exponent, and that would be x plus 1, what's inside, known as the argument, if you want to know what it is. 10 squared is 100. Subtract 1 and you get 99. Over here, if we have all logarithms or all natural logs, we want to get 1 on each side. So we combine. When you add, you combine by multiplying. And now we're solving for what's inside. So x times x plus 2 equals 8. Distribute, subtract that 8 over, and now we're factoring. So we get x plus 4, x minus 2, so x equals negative 4 and positive 2. But you have to check by plugging back into the original. If I plug in negative 4, you can't have log of negative 4. Remember domain restrictions. Anything inside of a log is greater than 0, so that's an extraneous solution. However, if I plug in a 2, I can have log of 2, I can have log of 4, and the only answer here would be x equals 2. So do make sure you can solve logarithms as well as know your rules of logarithms for this material.